Assalamualaikum and a very good afternoon to Dr. Nordic. My name is Muhammad Iqmal Haziq bin Khairul Anwar, number metric 199078. So today I'm going to present a video presentation of liquid characteristics and dimensional analysis. There are two methods of dimensional analysis. First is Rayleigh's method and second is Buckingham's theorem. So both of the methods I will explain after this. So the slide contents of my slide is, first is fluid characteristic. What does this it mean by fluid characteristic? How many types of fluid and what are the characteristics? Second is dimensional analysis. What does it mean? What are the uses and how many methods are there? Third and fourth is the method of dimensional analysis, which is Rayleigh's method and Buckingham's pi method. So the definition of fluid characteristic is fluid is defined as a substance which can flow. Technically, the flow of any substance means a continuous relative motion between different particles of the substance. The continuous relative motion between the particles of the fluid when shear force is acting on them. The particles of fluid move past each other when shear force is applied because they cannot resist the shear force, which means they are inelastic to shear stress. A fluid can deform under shear stress indefinitely without returning to its original position. So there are two types of fluid. First is gas and liquid. Gas will occupy the complete space available in the container and it was compressible volume. For liquid, volume remains definite even as it takes the shape of the surface on. Here are some of the fluid characteristics. First is specific volume. The ratio of volume substance to its mass. It is reciprocal of density and an intrinsic property of matter. Specific volume is defined as the number of cubic meters occupied by 1 kilogram of substance. The unit is meter cube per kilogram. The second one is specific weight. The weight per unit volume of a material. In fluid mechanics, specific weight represents the force exerted by gravity on a unit volume of a fluid. Units are expressed as force per unit volume, such as Newton over meter cube or pound over feet cube. The third one is viscosity, the fluid property that determines the amount of resistance of the fluid to shear stress. It is the property of the fluid due to which the fluid offers resistance to flow from one layer of the fluid over another adjacent layer. In a liquid, viscosity decreases with increase in temperature. In a gas, viscosity increases with increase in temperature. The last one is density, the mass per unit volume of a fluid. It is the ratio between mass and volume of the fluid. Density unit is kilogram per meter cube. In general, density of fluid decreases with increase in temperature. The density of standard liquid water is 1000 kilogram per meter cube. So I'm going to explain about dimensional analysis. Dimensional analysis means of simplifying a physical problem by appealing to dimensional homogeneity to reduce the number of relevant variables. The analysis involves the fundamental units of dimensions like mass, length and time. It is helpful in experimental work because it provides a guide to factors that significantly affect the studied phenomena. So there are two methods of dimensional analysis. First is Rayleigh's method. Rayleigh's method is an elementary method for finding a functional relationship with respect to a parameter in interest is the Rayleigh method. This form of dimensional analysis expresses a functional relationship of some variables in the form of an exponential equation. It was named after Lord Rayleigh. The second one is Buckingham's pi method. Buckingham's pi method theorem states that if there are n variables in a problem and these variables contain m primary dimensions, for example for mass, liquid and time, the equation relating all the variables will have m minus n dimensionless groups. So I'm going to explain about Rayleigh's method. First, gather all the independent variables that are likely not to influence the dependent variable. Next, if R is a variable that depends upon independent variables such as R1, R2, R3 until Rn, then the functional equation can be written as R equal to F multiplied by R1, R2, R3 until Rn. Next, write the above equation in the form of R equal to C, R1a, R2b, R3c, Rn, M, where C is a dimensionless constant and A, B, C until M are arbitrary exponents. Then, express each of the quantities in the equation in some base units in which the solution is required. After that, by using dimensional homogeneity, we must obtain a set of simultaneous equations involving the exponents A, B, C until M. Then we solve these equations to obtain the value of exponents A, B, C until M. Finally, substitute the values of exponents in the main equation and form the non-dimensional parameters by grouping the variables with like exponents. So this is the example of Rayleigh's method. Next, now I'll explain about Buckingham's pi method. Firstly, gather all the independent variables that are likely to influence the dependent variable. Next, if R is a variable that depends upon independent variables such as R1, R2, R3 until Rn, then the functional equation can be written as R equal to F multiplied by R1, R2, R3 until Rn. After that, we must count the number of variables, the dimensional quantities and number of pi groups, which mean m minus n. Then we pick the repeaters that obey the rules. Next, express pi in terms of the repeaters in terms of pi equals to pi equals to R1 multiplied by R2y multiplied by R3z until Rmn, where x, y, z until n are the arbitrary constants. So there are 5 steps are repeated according to number of pi groups. Finally, substitute the values of exponents in the main equation and form the non-dimensional parameters by grouping the variables with like exponent. So here are example for Buckingham's pi method. So I'm done for this video. Thank you. Assalamualaikum.